There are two things I want to explain to us. There's what is called the random experiment and the random variables in statistics. A random experiment in statistics is not like the usual experiment we do in physics and chemistry. Okay, so in statistics, when we talk about a random experiment, we are simply referring to an experiment that is performed irrespective of the number of times, and as much as possible the same condition that is maintained would at the end of the day produce different outcomes. For instance, when we throw a die, there are 6 possibilities: a 1, 2, 3, 4, 5, and 6. So that is a typical example of a random experiment. So you can obviously see that when such an experiment is carried out, we are not sure of the outcome, irrespective of how much we try to maintain the same condition. So that is a random experiment. So of course, when we talk about the random experiment, we are also going to be talking about the random variable. Okay, so before I do the random variable, we have what is called the sample space. Okay, so the sample space is simply a collection of possible outcomes. So when we throw a die, you realize that you have a 1, 2, 3, 4, 5, and 6. So that a collection of these values is simply your sample space. So when we relate real values to your sample space, the random variable helps us to do that. Now let's go back to the question. So the question says that suppose that a game is played with a single die, assumed fair. In this game, a player wins 20 naira if a 2 turns up. He wins 40 naira if a 4 turns up. He loses 30 naira if a 6 turns up. And while the player neither wins nor loses if any other face turns up. Okay, find the expected sum of money to be won at the end of the day by the player. So the first thing we are going to be doing is to generate what is called the probability distribution, table. Okay, so this is simply a collection of the possible values of the random variable together with the respective probability. We are going to represent the random variable by capital letter X, and then we have the probability that relates this random variable to different values. Okay, remember, the random variable is supposed to assign real values to the possible outcome of the experiment. He also mentioned that outside a 2, a 4, and a 6, any other value that turns up, okay, simply means that he did not win and he did not lose. Okay, so when a 1 turns up, it means that he did not win, at the same time he did not lose, so that's a 0. When a 2 comes up, so in place of a 2 we have a plus 20. He wins a 20 naira. Okay, when a 3 comes up, he neither wins nor loses anything. So when a 4 comes up, okay, they said here that he wins 40 naira if a 4 turns up. So in place of 4, we put plus 40. Okay, and then he loses 30 naira if a 6 turns up. So we have 1, 2, 3, 4. When a 5 turns up, it's going to be a 0 because he neither wins nor loses. And then obviously when a 6 turns up, he loses 30 naira. So we'll do minus 30. So let's relate probabilities to each of these values. And then we know our general definition of probability, right? Probability is supposed to be the number of expected events all over the total number of possible cases of that experiment. So the total number of possible cases of this experiment is 6. That is a 1, 2, 3, 4, 5, and 6. Okay, so the number of possible cases of a 1 coming up is simply 1 all over the total number of possible cases of the entire experiment. So what about when a 2 comes up? It's just 1. So it's still going to be 1 all over 6. When a 3 comes up, it's still going to be 1 all over 6. When a 4 comes up, it's still going to be 1 all over 6. When a 5 comes up, it's going to be 1 all over 6. And when a 6 comes up, which is obviously when he loses 13 naira, that is also going to be happening 1 time all over the possible number of times, which is 6. Okay, so this is 1 all over 6. So when we talk about expected sum of money, That takes us to a topic in statistics that is called expectation. Okay, so typically for expectation, which is generally denoted by E of the random variable x, expectation of this random variable in statistics is defined as summation of the possible values of this random variable, okay, times the probability related with each of these random variables. Okay, so at this point we are taking the sum over the possible values of the random variable. They are ranging from 1 to 6. So this is a discrete definition. Discrete is because the values of the random variable are countable. They are not continuous. They are not in an interval. Okay, so at this point, we'll pick the first random variable times it by the probability. So the first one here is a 0, okay, times the probability, which is a 1 all over 6, plus the second one is 20 times the probability, which is a 1 all over 6, plus 0 times the probability, which is a 1 all over 6, plus minus 30, okay, times the probability, which is a 1 all over 6. So if we times this will be 0 plus 20 all over 6 plus 0, okay, plus 40 all over 6 plus 0 plus another plus minus 30 all over 6. So this can be expressed as a 2 here is a 10 and a 2 down there is a 3, okay, plus a 20 all over 2 here is a 3, okay, this 0 is off, and then the plus minus brings the minus sign obviously here, okay, and then a 2 here is a 15, a 2 here is a 15 all over, a 2 here is a 3, okay. So at this point, taking the LCM is obviously 3, so a 3 here into here is 1 times 10 is 10, plus 3 into this is 1 times 20 is 20, minus 3 into this is 1 times 15 is 15. Okay, so at the end of the day, what do we have? Simplifying this, we have this plus this 30 minus 15 is a 15 all over 3, which is equal to 5. So therefore, the expected amount that the gambler would win, okay, the expected amount won, okay, at the end of the day, it's just going to be 5 naira. Please follow me for more videos. I'll see you guys on the next one. Bye bye.